So today we are going to discuss a new topic in the distillation column. So this topic is basically enthalpy composition diagram. Earlier we have discussed about the TXY diagram. This is temperature in composition diagram. Now we are going to discuss HXY. HXY diagram, how to develop it and what is the significance. So HXY, that is the enthalpy concentration data. What is the meaning of this one? So first we should know that we are going to develop this HXY diagram for the binary system. And in the binary system we are taken A and B. A is the light component and B is the heavy component. So in the enthalpy concentration diagram calculation, what we need, the first thing, latent heat. We all know what is the meaning of latent heat. It is basically the heat required to change the phase. For example, if anything is in the liquid phase, so the heat needed to change from liquid phase to vapor phase is latent heat. Here the heat is required, and if any material is in the vapor phase, then the heat will be released, latent heat will be released to convert the vapor phase of material into the liquid phase. Then the second thing that we should know is the heat of solution or heat of mixing. Since this is a binary system, means there are more than one component, not is a pure, that is a mixture. So obviously if you add A into B or B into A to make it solution, to make it mixture, so there are always a heat of solution is sometimes added or sometimes released from the mixture. It can be a positive or it can be a negative. So this is the meaning of heat of solution. Third thing is the sensible heat. Sensible heat is the heat required to change the temperature of any material, any mixture, any solution, keeping the phase unchanged or keeping the phase in a constant one. Means if any material in the liquid phase is 50 degrees Celsius and you supply the heat, you provide the heat, the material is now at 70 degrees Celsius in liquid phase. So in the in both cases, when before the supplying the heat, it is in the liquid phase, and after supplying the heat, it is again in the liquid phase. So what are the changes occurred in this one is only the temperature. So the heat supplied to raise the temperature is called as a sensible heat. In this case, no phases are changed. So this is the heat informations that we need to know. In these three one, the first one and third one are very important one. Now come to the development of HXY diagram. What are the data required for that thing? So this was the first one. Heat capacities, that is the CP value of the liquid. We need this value, and we know that it's a function of temperature, composition and pressure. It means that CP value will change with respect to temperature, with respect to composition, with respect to pressure. And if you fix the pressure, then there will be only two components, means temperature and composition. Similarly, heat of solution, this is also a function of temperature and composition. The third information, latent heat, this is also a function of temperature, composition and pressure. Boiling point, the boiling point means boiling point of mixture, that is the bubble point and dew point, because in the mixture boiling point is not the same. When the phase is changes from liquid to vapor, you will observe the different point as compared to the phase changes from vapor to liquid. So one is bubble point, the second is the dew point. So it is a function of temperature, composition, and pressure. And if you fix the pressure at a constant pressure, so what happens? This third variable will automatically cancelled because you are now not changing the pressure. So only you have two variables, temperature and composition, for calculation of heat capacities. So as we know that in the HXY diagram, there are two components. One is the HX and one is the HY. So now let us look about the first one, that is the HX diagram. So in the HX diagram, what we need, we have to find out first the reference temperature at a constant pressure. Normally the reference temperature is 0 degrees Celsius, and sometime it is the other values also. How to calculate the HX? So H, that is a heat, that is the enthalpy of the liquid with respect to the composition, that is X, in the form of kilojoule per kg or kilojoule per kilomole, is calculated by this equation. This enthalpy of the saturated liquid is calculated by this parameter. So here there are three components. First component is this one, second is this one, and third is this one. So what are these values? XA, that is available in first one, in this one, is the mole fraction of a liquid A. So a simple one. This is a CPA and CPB. It is the heat capacity of liquid A and B in kilojoule per kg degree Celsius. T naught, this value, it is the reference temperature. T, this value, it is a boiling point of mixture. Delta H solution is the heat of solution at T naught kilojoule per kilomole. Now this value is a very small value. If the heat evolve on the mixing, delta H will be a negative one, but normally these values are very small as compared to these two parameters. That is why we can ignore the delta H solution value and it can be neglected. So finally you get this value, this one, for the calculation of HX. This calculation. So please remember this equation for the calculation of HX value, HX data. How we can calculate it? See, this is a TXY diagram, and if this is taken as 70 degrees Celsius is taken as a reference temperature. So for the saturated liquid, this is a saturated liquid condition. At any given composition, we can find out the temperature of the saturated liquid. This is the temperature. This is about 101 degrees Celsius. So this is a T naught and this is a T value, this one. So T naught is given, T value is given, composition is 0.25%, composition X is given. So in the previous equation, if you see that, so X is given, T is given, T naught is given, only CP A and CP B is required, composition is also calculated. So in this way we can find it. Now the second part of the HXY diagram is the HY diagram. How to calculate it? So we can calculate either in the kilojoule per kilomole or kilojoule per kg by this formula, where this capital H, that is the enthalpy of a liquid, a saturated vapor, that can be required by this. This two terms are basically used for the calculation. In this one, Ya is the mole fraction of A in saturated vapor. This value you can find out with the help of the information given for the saturated vapor. Then CPYA, CPYB, these two values are the vapor heat capacities of A and B. Then lambda A and lambda B value, These two values are the latent heat at the reference temperature T0. So how to find this latent heat of A and B at a reference temperature, because it can be any temperature. So for that thing we can go for this correction, means this concept, latent heat of vaporization correction. Say for example, this is our reference temperature 70 degree. This is the temperature of the boiling point of material A, and this is the temperature of the boiling point of material B, pure material. Then what happened? How to calculate the lambda A, that is the latent heat of vaporization? So it's very simple. We assume that we are now at this position, liquid phase at T0. Temperature is provided from this position so that we can reach at this position, liquid phase, but at this temperature. So how we can calculate this value? So this value can be calculated by Cp TBA minus T0. Okay, then vaporization will be started and the material A will be vaporized into the from liquid to vapor phase. So the one thing will be added here, and that is nothing but that latent heat of vaporization of this A. After that, say for example, now it is added here. At the same temperature we get the material into the vapor phase. So now let's just assume that we are going to cool down it, but the only condition is that it should be present in the vapor phase. So if you cool down it from one vapor phase, from this temperature to this temperature in the vapor phase, so it means that cooling means that heat is releasing from that material. So you have to put the value minus Cpya. It is the vapor phase heat capacity, and then the difference between these two temperatures, TBA minus T0, means between these two temperatures. That basically give the concept of lambda A. And the same thing is for the lambda B, means condition is here, liquid phase, supplying the heat. Condition is now as a pure B, liquid phase, then changes into the vapor phase, then cool down into the vapor phase, and then we have reached at the reference temperature. So this is the basically to the concept of lambda A and lambda B. We can use these two equations in the calculation of the HY diagram. Now let us take one problem where the property of A and B is given here, their boiling point is given, and their liquid capacity in kilojoule per kg mole degree Celsius is given. Vapor heat capacity is also given. Latent heat of vaporization kg per kg mole is also given. Reference temperature can be taken as the boiling point of A, that is 80 degree. So if you take this value, automatically the enthalpy of the A will be 0, because it is taken as the change in the enthalpy is 0 because it is taken as boiling point of A. So the reference temperature is given here. So we have a temperature range of the for developing the HXY with the help of TXY. So 80, 85, 90, 95, 100, 100, 510. These are temperature range. X value is given here. Y value is given here basically here. The TXY is given here. What we can do, we have to apply this equation. So we know this CPA value is given, that is a liquid enthalpy. T0 is now given, it is 80. T is given here. These are temperature for the T, and all the other parameters are known to us, and we can find out the H value. So H kilojoule per kilojoule per kilomole is given with the help of this equation. Now going for the calculation of capital H, that is the enthalpy of vapor. For that thing we have to correct our vaporization concept, and we have to find out the lambda A and lambda B value, that is for the correction of the lambda value that is being used here. So this CPA, CPYA, CPB, CPYB, both our four values are given. Temperature difference and boiling points are also given. This temperature of latent evaporation for the pure component are also given. So with the help of all these known parameters, we can find out the L, lambda A and lambda B that comes around be this value 30,820 and 34,209. So now put these values in this enthalpy calculation and you can find out the capital H, that is the enthalpy of a saturated vapor. So we have a X and Y values of H. You can draw this line. You'll find that this is the HX. This is HY and this is the HX. So, and overall this is called as the HXY diagram. So in this way we can develop this HXY diagram using the basic concept and basic formula for the calculation of enthalpy of the saturated vapor and saturated liquid. Thank you very much.